Let's use a couple of series and the manipulations that we're allowed to do to find some values. The first one that I want to do is I want to find a series for x cosine x, and I'm going to be given a basic series formula for cosine. So given that the cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and on and on and on. Or, if you prefer, you could say that this is equal to the sum, n equals 0 to infinity, x to the 2n power, 2 times 0, 2 times 1, 2 times 2, 2 times 3, so x to the 2n power. It's over 2n factorial, so we've got 2n factorial, and then it goes every other one as positive and negative, starts out positive, so I'm going to put negative 1 to the n, so negative 1 to the 0, and then to the first, and so forth. So there is a series for cosine x. Now, we can take this and multiply through by x. So let's do that. X cosine x is equal to, well, it's equal to x minus x cubed over 2 factorial plus x to the 5th over 4 factorial, just multiplying by x, minus x to the 7th over 6 factorial, and so forth. Well, notice what that's equal to. That is n equals 0 to infinity. It's just like multiplying each one of these by x, so I get x to the 2n plus 1, that's that extra factor of x, got minus 1 to the n over 2n all factorial. So that works pretty well. Now let's try something else. Let's use a series to find a limit. Let's assume that we've got a problem given to us. The limit as x approaches 0 of e to the x subtract 1 divided by x. Now if you look at that, you can try to use L'Hopital's rule. You can do a lot of things. You get 0 over 0, all right? Well, instead of doing all the techniques that you have probably learned in calculus before, let's write a series for this, because that's the complex part. So instead of writing e to the x, we are going to write it as a series. So we've got x approaches 0, e to the x, a basic formula for that. A basic series formula is that it is the series n equals 0 to infinity x to the n over n factorial. So we've got that. We've got to subtract 1, and we've got to divide by x. Well, let me get a few terms out here so that what we're going to do kind of makes a little bit more sense. So let's take the limit as x goes to 0. And I'm just going to write a few of these. So x to the 0 is 1 over 0 factorial. And then the second one would be when n is 1, so that's x to the 1st over 1 factorial. And the next one would be x squared over 2 factorial. And the next one, x to the 3rd over 3 factorial, and on, okay? So we've got that. Then we've got to subtract 1, and we've got to divide by x. Well, let's check this out. We've got 1 here, we've got minus 1 here, so those actually drop out. And then we could go through and divide each term by x. So we end up having the limit as x goes to 0 of this. We've got 1, because it's x over x, so that is 1, plus x to the 1st over 2 factorial, plus x to the 2nd, these are all dropping down by 1 power of x, over 3 factorial. Next one, if we had it written down, would be x to the third over 4 factorial, etc. Well, you send x to 0, look what you get. You get 1. Kind of a nice result of using series.